Hello, my dear class 10 students. Welcome back. So today we'll continue with the part 4 for chapter 4, Science, Carbon and its Compound. And in the last class we were discussing about the functional groups, and we have discussed two types of functional group, that is halogen and alcohol, right? So today we'll discuss some more functional groups which are mentioned in your text. Now this chapter is a little long, and all the topics are very important, clear. So you have to make note of every explanation, every point that we are discussing, clear. So now let's discuss about the third type for functional group. Okay, functional group. So the third type of functional group would be carboxylic acid. Carboxylic acid. Clear? Carboxylic acid. Now this is the carboxylic acid, okay? And this one you'll find like this. Clear? This is the formula, clear, for carboxylic acid. Now whenever we have this carboxylic, okay, whenever we have this carboxylic as a functional group in a compound, now the name would change, okay. Now as you know, like the functional group, they are an atom or a group of atom that determines the chemical properties of a compound. That is what I have said in the last class. So let me give you an example. If like there is a functional group in a compound, clear? So I have here an ethane, okay. I have here an ethane, and if this carboxylic comes and be a part of this compound, then it will change to see. So my dear students, you can see this over here, right? See, this COOH in this compound, right? In ethane, now COOH is acting as a functional group. So now it has changed. So it was ethane, right? This is ethane, but now when this functional group comes and be a part of this compound, the name would change to ethanoic acid. Clear? Oic acid. So you have to remember that for carboxylic acid, while naming, okay, for IUPAC name, the suffix should be oic. Okay, oic. So see, it was ethane, but now when we have this COOH, carboxylic acid, as a functional group, the name is ethanoic, right? Oic. So you have to remember this one. Clear? Now let me show you another example, okay? Now this is for ethane and ethanoic, right? Now let's see what will happen if we have a functional group COOH in a propane, okay? Okay, so students, now this is propane, okay? Propane. Now let's see if we have this COOH in a propane. See, students, it's very simple, it's similar, okay? Now we can see that there are 4 bonds, right? 1, 2, 3, 4 surrounding the carbon. So now in this case, this is propane, but we have propane plus the functional group is carboxylic acid, so it will be oic, okay? So it will be propanoic acid, clear? See, so the name has changed. So this is our third functional group, and let's see another 2 functional group, okay? So that will be aldehyde. My dear students, the 4th functional group that we are going to discuss would be aldehyde, okay? Aldehyde. Now, while naming, okay, while we are writing the IUPAC name, if we have aldehyde as a functional group, then the suffix would be, that means the last word, okay, while naming, the last word would be al, okay, al, al. Clear, see, aldehyde, so the suffix will be al, al, okay. Now, CHO is an aldehyde, okay, CHO is an aldehyde. So now, this one you will see as C. So this is how it will look like, okay, in a compound. In the formula, this is how it will look like, the functional group. So this one will be aldehyde. Now, let's see, okay, let's take the same example from propane, okay. From propane, if we have this aldehyde as a functional group, how it will change? So this is our propane. Now, if we have this aldehyde as a functional group in propane, then it will replace the hydrogen, okay? It would not replace the carbon, keep in mind. The central atom it will not replace. Okay, so students, this is how it will look like, okay? This is how it will look like, and then you have to see that we have four bonds surrounding this carbon, okay? Now, how we are going to name this one? We'll name it as a word root plus suffix, right? So word root means we have 3 carbons, so it will be propane, right? Propane. And then what is the suffix? Here the suffix means the functional group. So what is the functional group? We have CHO as a functional group. So if we have CHO as a functional group, then the suffix would be al, right? So it will be propanal, okay? Propanal. So sometimes in MCQ question, you will get to see like 4 choice, okay, of different formula, and you'll be asked to name what kind of functional group it is. So you have to differentiate by seeing the functional group in a compound. So whenever you have CHO, that means there is an aldehyde. And like I have said, if you see COOH, that is a carboxylic acid, okay. Now let's see the 5th type, okay. So this will be the last type of the functional group that we'll discuss, that will be ketone, okay, ketone. Okay, so my dear students, the 5th type of functional group, that would be ketone, okay, Ketone, ketone. Now, if we have ketone as a functional group, now the suffix will change with ONE, on, okay. In the suffix, we are going to write ONE. That means while we are naming, okay, while we are giving the IUPAC name, we will use the suffix ONE for a functional group ketone. And now ketone is CO. Clear? If you have this CO, that means how it will look like. I'll show you here, okay? It will look like this. Clear? So if we have CO, then that is ketone. So now let's try to substitute this functional group in this propane, okay? See, we have already substituted, okay, this ketone in the propane. Now we'll try to name this compound. So in order to name the compound, we have this formula, word root plus suffix. Clear? So this is the simplest way to write the IUPAC name, word root and suffix. So word root, we have 3 carbon, so we'll write propane, right? Propane. Now, what is the suffix? Suffix, we always refer to the functional group, and the functional group is ketone. So we'll write ONE, right? So students, this is the IUPAC name, propanone, right? propanone. Okay, so this is how we use this functional group in a compound. Okay, and I'm saying again, but this functional group, they play a very important role in a compound, because as soon as they come and be a part of this compound, they change the chemical property of the compound. Okay, they determine the chemical property of a compound. So that is all about the functional group. Now we'll see another next topic, that will be chemical properties of carbon. Okay, so my dear students, next topic would be chemical properties of a carbon. Chemical property of carbon. Clear? So we'll discuss 4 types of chemical properties as mentioned in your textbook, and also you can refer page 58 to 78. Okay, so the first type would be addition reaction. Addition reaction. Clear? Now the second type would be combustion reaction. And the third type would be oxidation reaction. And the last type of chemical property that we will study would be substitution reaction. Substitution reaction. Now my dear students, see, you have to focus on the name. Okay, this name, we have to focus on this name, because it will be related with the name. Okay, addition means what? Adding, right? So here it is to do with adding. Now combustion means what? Burning, right? Oxidation means adding oxygen, removal of hydrogen. Substitution means their replacing is going to take place. Okay, so now let's see about this addition reaction. Okay, now here in this addition reaction, an unsaturated compound. Okay, see, unsaturated compound. Now in any unsaturated compound, we will add molecules such as hydrogen or chlorine. Okay, we'll add hydrogen or chlorine to make it what? To make it saturated. See, this is an addition reaction, but they can ask a question in a different way. They can ask like, how you will convert an unsaturated compound into a saturated compound. Clear? They can ask you in this way, how you will convert this unsaturated into saturated way. So we can convert this unsaturated into saturated by adding hydrogen. Okay, by adding molecules like hydrogen or chlorine in the presence of catalyst. We need a catalyst. Okay, what is catalyst? Catalyst is to faster the reaction. Okay, now so students, let's say an unsaturated compound. Unsaturated means we have studied about alkene and alkyne, right? So we'll use the first member of the easiest one, alkene. Okay, so that will be C2H4. Clear? C2H4. Now here let's add hydrogen. Okay, we'll add hydrogen. Now what do we need in order to faster, in order to make this reaction very fast, quick? We need a catalyst. And what is the name of that catalyst? We can use either nickel. We can use either nickel or palladium. Palladium. Clear? So we are using nickel. Okay, we are using nickel as a catalyst. Now what will happen? Okay, nickel catalyst. However, now when we react this one, we'll get C2H6. Now students, we all know that C2H6 is ethane, right? And this is ethene, right? So this is what? unsaturated, right? This is unsaturated and this is saturated. So this is addition. In addition reaction, see students, just focus on the chemical reaction. It's very simple. In C2H4, we have added H2, right? We have added 2 hydrogen means it's becoming C2H6, clear? So from ethene, we are getting ethane. From unsaturated, it is becoming saturated by adding hydrogen here, okay? And for this, we need a catalyst. We need something to get this product. And what is the name of that catalyst? We are using nickel, okay? You can also use palladium, clear? So, see, just if you know this chemical reaction, then you, for definition, you can just explain this reaction, clear? In an unsaturated, if we react an unsaturated compound with a molecule like hydrogen or chlorine in the presence of a catalyst such as nickel or palladium, then we'll get what? We'll get saturated hydrocarbon, saturated compound. Clear? So that is all about addition reaction. Now let's discuss about combustion reaction. Okay, combustion reaction. So students, this is the second type of chemical property, that is combustion reaction. Now combustion is to do with burning, right? Combustion is to do with burning. So carbon, okay, carbon in all its allotrope form, we have 3 allotropes of carbon as mentioned in your textbook. What are they? They are diamond, they are graphite, and they are fullerene. So now in combustion reaction, what will happen? In combustion reaction, carbon, okay, carbon will burn in the presence of oxygen to give carbon dioxide. Okay, very simple. All the carbon will burn in the presence of air, that means oxygen, to give carbon dioxide along with the evolution of heat and light. Okay, so students, this is the simple reaction. See, carbon, right, carbon reacting with oxygen in the presence of air, okay, to give what? Carbon dioxide. Done. Now, along with evolution of heat and light. So that is a simple definition of combustion reaction. Carbon would react with oxygen, okay, or carbon burning in the presence of oxygen or air to give carbon dioxide along with the evolution of heat and light. So that is combustion. And all the allotropes of carbon, and this diamond, graphite, and fullerene will burn completely, and they will give what? Carbon dioxide. So that is all about combustion reaction. So we are done with 2 types of chemical property. In the next class, we'll see oxidation reaction as well as substitution reaction. Clear? So thank you so much, students.